In the question number 31, a cricket ball of mass 100 gram has initial velocity 3i plus 4j cap and final velocity minus 3i minus 4j cap. After being hit by the bat, magnitude of impulse on the bat by the ball will be. So this is a formula based question. If I go for the impulse momentum theorem, then you know I need final linear momentum minus initial linear momentum. And you know the mass I need, first mass is 100 gram. So if I convert into kilogram and I'm going to take common, mass को मैं common ले रहा हूँ, and I need final velocity, that is minus 3i cap minus 4j cap subtracted by initial velocity minus 3i, and that will be minus 4j. So when you will calculate, you will get 0.1 minus 6i minus 8j. On solving the magnitude of impulse, we will get 1 Newton second. So my option number 2 will be the right choice. So let's move on question number 32. In the problem number 32, a block of mass 1 kg is placed on a periphery of a rotating rough circular table of radius 50 cm as shown in the figure. Angular velocity of the table is 4 radian per second. Okay. The minimum value of coefficient of friction between the contact such that there is no relative sloping. So, very clear, this is centrifugal force, and this force will try to pull the body in outside. Then you know the direction of friction always opposite to the relative motion, so friction will act on this direction. If there is no sloping, then this is possible only if maximum frictional force will be equal or greater than mr omega square. So you need friction force, that is mu mg, and mr omega square. Mass will cancel out, so mu will be greater or equal to r omega square by g. When I will place the value 50 into 10 to the power minus 2 is the radius, and angular velocity is 4 radian per second, divided by 10. So when you will solve, you will get 80 into 10 to the power minus 2. So I can say the minimum value of coefficient of friction is 0.8. So by this discussion, I can say my option number 1 will be the right choice. So let's move on question number 33. In the question number 33, when force 6i minus 2j cap Newton displaces a particle by 2i plus 3j, then average power is 0.4 watt. The time of action of force is. You know the formula of power is work upon time. So first I need the work, and you can calculate work by using F dot dr. You have the value of force 6i minus 2j, and the displacement is 2i plus 3j. So when you will calculate, you will get 6 joule. Now I have the value of work done. So if I use this relation, the work done by T, that is equal P. So work is 6, time T is our requirement, and power is 0.4. So when I will go for the time, 60 by 4. So that will give you 15 seconds. So this is required time. So I can say my option number 4 will be the right choice. Let's move on question number 34. If I go for question number 34, then we'll see the velocity of a body of mass m revolving in a vertical circle of radius r. At the lowest point, 2 root 2 gr, the minimum tension in the string will be. So as per the question, the lowest point, the velocity is root 2 gr, and tension if I go for point P, because question is asking to us the minimum tension in the string will be, and lowest point velocity are given. So tension will act and weight mg will act toward the center. So first I am going to use the law of conservation of mechanical energy. So you know, before going to use the law of conservation, you need frame of reference. So I am going to take the bottom part as a reference point. By the law of conservation of mechanical energy, I need initial kinetic, initial potential, final kinetic and final potential. So initial kinetic energy half. As you know, speed is given 2 root 2gr with square, and because I'm going to start from this point, so there is no position, there is no height, so initial potential energy will be 0, and final kinetic energy, if I say at this point speed is v1 and this point if speed is v2. So now suppose this is v1 and this is v2. So I'm going to write here m2gr, because total height will becomes 2r, just equal to the diameter, and the kinetic energy half m v2 square. So when you will solve, you will get the value of v2 is 2gr on solving, because you need this equation. So I have, when you will solve, because mass will cancel, you will take the square and will get v2 2 root gr. Now if I go at point P once again, then you will see the tension T and mg both are acting in same direction, and that is equal mass into acceleration, because this is a circular motion. So in the case of acceleration, I will write v2 square by r. So when you will calculate, you will get T plus mg, because I had the value of v2 square, and that is 2 root gr. So when you will put the value here, 4 gr, r will cancel. I had T equal 4 mg minus mg, so that will give you finally the tension is 3 mg. So that is how you can deal this question. So my option number 3rd will be the right choice. Let's move on question number 35. In the question number 35, a ball P is moving with a certain velocity, collide head on with another ball Q of same mass. So you have to be very careful, masses are same, and second body is at rest also. The coefficient of restitution is 1 by 4. Then ratio of velocity of P and Q just after the collision. So here I am going to use the formula of coefficient of restitution. You know, this is the situation. Suppose initial velocity is v0 and second body is at rest. After collision, if I consider first body has v1 and second body has v2. So if I use the concept of coefficient of restitution, then relative velocity after separation and relative velocity for approaching, because second body was at rest, that's why I am using 0 here. Coefficient of restitution is 1 by 4, so that will give you v2 minus v1 upon v0. If I go for v0, v0 is the initial velocity of this body, v0 will give you 4 v2 minus v1. If I consider, this is my equation number 1. Similarly, now if I go for the law of conservation of linear momentum, because you know, if there is no impulsive force, then the law of conservation of linear momentum will be applicable. So initial momentum was mv0 and final mv1 plus mv2. You have to be very careful, masses are same, mass will cancel out. So you have v1 plus v2 equal v0, and this is my equation number 2. Here you are seeing that equation number 1 and equation number 2, the left hand sides are equal, so we can compare by equation 1 and 2. Now I am going to compare equation 1 and 2. So we'll get, I am going to take this one, so we'll write 4 times of v2, 4 times of v1, that is equal v1 plus v2. So when you will rearrange v1 in one side and v2 in another side, and then you will solve, will get v1 upon v2, that is equal 3 upon 5. So this is our required ratio. So I can say my option number 1 will be the right choice. So let's move on question number 36.